2.2, Example 1. Determining horizontal asymptotes. So in this example, we're going to find the limit as x goes to infinity of f of x and the limit as x approaches negative infinity of f of x. And then we're going to use those limits to determine the horizontal asymptotes. The function that we're going to be determining the horizontal asymptotes of is x divided by the square root of x squared plus 1. Now, most of us don't know what this looks like on the top of our head. So before we determine algebraically how to do it, we're going to look at how to do it graphically. Graphically is probably the easiest method if you're allowed to use your calculator. So the first thing we're going to do is graph it on our calculator. So the first thing we need to do is graph it. So when you graph it, you push y equals, and then we're going to make the fraction again. So you hit alpha y equals, and then you push enter, and that gives you the fraction. And then you're going to push x divided by, and to get the square root symbol, it's second square root, and then x squared plus 1, and we're going to push graph. So right away we can kind of see the horizontal asymptote occurring at y equals 1, but now we're going to change the window so we can really see it. So you push window, we're going to let our x min be a very large number, like for example, we'll use negative 1,000. X max, we'll use 1,000. And for y min, I'm going to actually only use 2, or negative 2 to 2. And I'm going to push graph. And what this is going to do, it's going to make it very clear what's going on. So I can see right away that right here, it's an asymptote, because this is like negative 1,000, and this is positive 1,000. So I can see the asymptote occurs at y equals negative 1 and 1. Now I recommend you draw this in your notes. So this is the zoomed in version. And we'll notice that these x values are negative 60 and 60. So notice those aren't too large. And now let's look at the zoomed out version, and you're going to want to have this drawn as well. You'll notice these x values are incredibly large. And so as you zoom out, you'll notice that the y value approaches y equals negative 1 and y equals 1. So that's going to give you the horizontal asymptotes. So if we want to write that out, it's the limit as x approaches infinity of f of x is equal to 1, and the limit as x approaches negative infinity of f of x is equal to negative 1, which means we have a horizontal asymptote of y equals negative 1 and y equals 1. So it's also important to point out that the squeeze theorem also works for infinite limits. Now this next one I want you to try to determine on your own. F of x is equal to the absolute value of x divided by the absolute value of x plus 1. And I want you to determine the limits as x approaches infinity and the limits as x approaches negative infinity, and then tell me what the horizontal asymptotes are. So right now, pause the video, give that a try. Alright, let's look at it. So the first thing we need to do is graph it. So if we graph it on your calculator, it'll look like this. So to graph this on your calculator, you're going to hit alpha y equals enter to get that fraction. And to get the absolute value bar, you're going to push alpha F2, and you'll get these shortcuts. And so we want the absolute value. Push graph. Now my window is really messed up, so I need to fix that. Although zoomed out, you can kind of tell what the asymptote's going to be. But if we wanted to fix it, you push zoom and then 0, and the calculator will actually think what it thinks the window should be. So my window still looks pretty weird, so I'm going to manually adjust that now by pushing. I'm going to look what the window said it should be. Negative 1,000 seems pretty large. I'm just going to do negative 30. And then I'm going to do 30 on here. And then notice that the graph went to the very top, so I'm actually going to increase this to 2. And then hit graph. And now I'll see I have a much more reasonable looking graph. So now if we look at this graph, we can determine the asymptote, and it looks like we have a horizontal asymptote right here. And this is the line y equals 1. So going back to our original problem, the limit as x approaches infinity is 1, and the limit as x approaches negative infinity is also 1. So the only horizontal asymptote we have here is y equals 1.